Let's start with second condition. So my second condition is over a to b, I'll be taking only one function and square of that. Let's check what happens. So my range is 0 to pi by 2 fm of x the whole square, so that makes sine square 2m plus 1 into dx. So now we can say here 0 to pi by 2 sine square theta is nothing but 1 minus cos of 2 into 2m plus 1 into x divided by 2 dx. So which comes 1 by 2 integration of 1 is x minus integration of cos comes to be sine of 2m plus 1 into x divides by 2 into 2m plus 1 0 pi by 2. So now again here when you put pi, so that becomes, when you put pi by 2 and 2 cancel, then sin pi series is 0 and again sin 0 is 0, so only this term works. So it comes 1 by 2 pi by 2 minus 0 will be putting in the place of x, that is upper minus lower, so I get pi by 2, and which finally I get as pi by 4, which is not equal to 0. So basically we can say that our function is orthogonal. So I say therefore given set of function is orthogonal over 0 to pi by 2. To find orthonormal function, we have already proved one condition, and we know that whenever function is orthogonal, to prove or to find orthonormal functions, we'll be starting with my second condition of orthogonal. So I can say that if this set is to be orthonormal, then it should be nothing but from 0 to pi by 2 fm of x the whole square dx should be equal to 1. So but what we have got here, see if you can see, I got as pi by 4. So obviously I need to divide both sides by pi by 4. So now I just put a step here, divide both sides by pi by 4. So I get here 0 to pi by 2. So when I divide by pi by 4, that I can write as 4 by pi fm of x the whole square dx, and here I can write 4 by pi into, my answer was pi by 4, which comes to be 1. So for a set of function, I can split this function from 2 by root pi fm of x into 2 by root pi fm of x dx, and that's equal to 1. So now I can say, with respect to this, I can say that a new orthonormal set, I say here orthonormal set function, let's define by phi n, that is nothing but 2 by root pi fm of x, nothing but you can write as sine of 2m plus 1 into x. So that's my function which I got. When you put values of m, the required orthonormal set of functions I'll be getting as, so let's put here therefore required set of orthonormal function is, starting with 1, 2, 3, when you put 0 it will be obviously 0. Let's start with 1, so that comes 2 by root pi sin x, 2 by root pi sin 3x, 2 by root pi sin 5x, and further you'll be getting all odd terms. So that is my set of orthonormal function. Thank you for watching video on in 5 minutes.